If you'd like to secure your SSH server by adding Google Authenticator's one-time passwords, then this video is for you. We'll talk about what one-time passwords are and how to generate them, how to set up Google Authenticator's Linux library, how to configure PAM and SSH for keyboard interactive authentication, how to protect SUDO access with one-time passwords. Hi, my name is Filip. Let's continue with our SSH Linux tips. In today's world, data privacy is extremely important. Protecting your online services with just a password is extremely risky. In order to secure your SSH account, a second authentication factor, a second way to verify user's identity, needs to be implemented. If you'd like to hear more about multi-factor authentication, please take a look at this video here, where I explain that in more detail. Usually, the first level of authentication is something that you know. That is, for example, username and password. Most common second-factor authentication is one-time password generated by an application on your mobile phone. With this approach, for someone to log into your account, they need to know both the username and password, but also need to have your phone to enter the code generated by your Authenticator application. Before we go into SSH setup to support one-time passwords, let's briefly discuss what one-time passwords are, how they work, and why they are so popular and secure. In order to understand one-time passwords, let me introduce a concept of hash function. Hash function is a mathematical function that takes some data and produces a fixed size output called a hash. Hash function will produce the same result, same message digest for the same input data. Any change in the input data will produce a completely different hash value. Hash functions are commonly used, among many other things, to check data integrity. Most likely you've heard about MD5 or SHA-1. Let's see how it works by generating a sum. We have a test.txt file with the following content. Let's calculate the MD5 sum for that file. If we calculate the sum one more time, the result is the same. Let's change the file in a tiny bit and recalculate the sum. As you can see, the result is totally different. So just to recap, hash function creates a fixed length size output of any input data no matter the length. Hash function will provide the same result for same input. It's not possible to reverse engineer input from the output. Any change in the input will produce a different result. Now let's go back to our one-time passwords. Hash function is the basis of one-time passwords. Most basic one-time password type is called HOTP. That stands for Hashed-Based Message Authentication One-Time Password. The HOTP algorithm takes two input values. One is a secret key that is static, and the second value is a counter that increases every time a new code is generated. The output is a 6-digit number. Hash function takes a static secret and combines it with a counter that increases and produces the same code for the same input parameters. Let me show you. We need to install an OATH tool first that can generate the one-time passwords. Now let's provide 00 as the code and 0 as the counter. Let's try that again. As you can see, if the secret key is 00 and the counter is 0, we get the 328482 code. Let's increase the counter. Let's change the secret. Server and the client don't need to talk to each other. They don't need to have internet access. As long as they share the same secret key and use the same counter value, both will get the same code. Secret key is exchanged only once upon initial configuration. HOTP codes have some issues, with the main one being synchronization of the counter. Every time a user authenticates, the counter increases. If the counter gets out of sync, it's not that easy to fix. Much more secure and common way to generate one-time codes is called TOTP. That stands for Time-Based One-Time Passwords. This algorithm generates one-time password based on a secret key that is static, and as you can easily guess, the second factor is current time. The code usually changes every 30 seconds. Let's try generating a few one-time based codes. I will put 00 as the secret key and TOTP parameter to indicate that I want to generate time-based code. If you try to reproduce this yourself, you will get completely different results because despite the secret key being the same, the time of generation is different. There is also a parameter where you can specify the exact time of generation in the future or in the past. To recap, one-time codes are based on a shared secret and a variable. In hashed, the variable is a counter that increases every time user authenticates. In time-based one-time passwords, the variable is the current time when the code is generated. Timecode usually changes every 30 seconds. For time-based code to work, server and the client needs to have time synchronized. Server and the client don't need to have internet access. Google has their own mobile application capable of generating one-time passwords called Google Authenticator. In this example, we'll use a dedicated library they did release called Linux PAM Google Authenticator for secure access to our SSH server. First thing first, in order for time-based one-time passwords to work, we need to have our time perfectly synchronized between server and the authenticator device. If there's a time skew of more than 30 seconds, the codes will not match. Let's check if our system clock is synchronized and if our time synchronization service is running. Now, as the time is synchronized, let's install the required tools. Next step is to run Google Authenticator command to generate our secret key that will be used during one-time password generation. I'm adding the Q option to generate a small QR code that we can scan with our Google Authenticator app on our mobile phone. You'll be asked a bunch of questions. First is if you want your codes to be time-based or hash-based. Of course, time-based is more secure. We'll be given the secret key and a QR code. Please scan the QR code with your Google Authenticator application or enter the code. Please mind that this secret key is not synchronized with Google Cloud. It's provided initially, and if you lose your phone, you won't be able to restore it. It's best to save this code somewhere safe, in case you lose access to your application. Okay, we have the secret key and the application is asking us to generate a code. You'll be doing it with the Google Authenticator application on your phone. But for demo purposes, I'll use OAuth tool. Let me generate the code and put it in the application. Google Authenticator application on your server will store its configuration in .google authenticator file in your home directory. Next question is about disallowing multiple users to use the same code. It says it will restrict one login per 30 seconds. We are fine with that. Do we allow for any time skew? No. Do we want rate limiting set to 3 logins every 30 seconds? Yes. Let's now look at the file that the application generated. As you can see, the format is pretty basic. First line has the secret key. Next 3 lines are the rate limitation parameters, information about reusing the code, and that will be using time-based one-time passwords. Every user that wants to have Google Authenticator enabled needs to have their own .google authenticator file present in their home directory. It's not recommended to share the configuration file for all. To recap, For time-based codes to work, your clock needs to be in sync. Google Authenticator Linux application will generate a secret key. You can scan it with your phone or type it in. As both server and Google Authenticator app on our phone have the same secret key, let's move to PAM and SSH configuration. PAM stands for Pluggable Authentication Modules, and it's basically a framework for authentication in Linux. Let's go to PAMD and we'll find the SSH file there. It holds SSH-related configuration. Now let's add the following line. Auth stands for authentication. Required means that this module needs to succeed for the authentication to be successful. Basically, if a required module fails, the authentication is terminated immediately, and the user is denied access. The null OK parameter, what it does is, it allows for Google Authenticator to be bypassed if someone does not have it configured on their account. If you remove null OK parameter, then because this module is required, Google Authenticator will be enforced for all SSH access. That will break any non-interactive connections. If you don't have any non-interactive connections, you can remove null OK parameter once you have all accounts set up for Google Authenticator. That is, everyone has a Google Authenticator file in their home folder. Modifications to PAM have immediate effect. Let's enable keyboard interactive authentication in SSH by editing SSH configuration file and setting keyboard interactive parameter to yes. Keyboard interactive means that the user will be asked for some additional information like one-time password or authentication token beyond just the password. In older SSH version, this parameter was called challenge response authentication. For the setting to take effect, let's restart SSH service. Now, let's try connecting. You'll be prompted for a password and then for one-time token. Let's generate one with an OAuth tool. Obviously, you can also grab your one-time code from Google Authenticator app on your mobile phone. I'm just using OAuth tool for demo purposes. Okay, we are in. In order to make our lives easier, we can make the one-time password visible. Let's do that by adding echo verification code parameter to the Google PAM module. Let's try connecting. The code is visible. Just to recap, you need to add Google Authentication module to PAM. You need to set null OK parameter so people without Authenticator module configured can still log in. You can enable echo parameter to see the code that you are typing. You need to enable keyboard interactive login in SSH and restart the service. Let's secure our SSH service even more by adding an SSH key to the mix. I will generate an SSH key and copy it to the remote system. I'm asked for a password and one-time code during the copy. Okay, let's try connecting. It works. But wait, why? It did not ask for one-time password. But let us in immediately. Let me explain. If you enable any of the authentication methods in your SSHD config file, like public key authentication or keyboard interactive authentication, SSH will let you in if any of those authentication methods are successful. If you want to be allowed in only if both methods are successful, we need to explicitly set it up. Luckily, there's a configuration parameter in SSHD that does exactly that. Let's open SSHD config and add the following lines. Match user will apply this parameter only to specific users. If you don't specify match user, then our changes will be applied to all users. Now, let's specify that we want both public key and keyboard interactive authentication to be successful in order to log in. Let's restart SSH service and try connecting. I will add a verbose option to get more details. As you can see, public key authentication was successful, but SSH is saying it's only a partial success. As now, we need to enter the token. Okay, we are in. If you connect with SSH multiple times a day, entering the code every time can be a bit cumbersome. There's a special parameter called grace period. Let's add it to the PAM. You can specify time in seconds, where you won't be asked for the code. So, you just authenticate with code once, and for the next 1 hour, you won't be asked for a new code. Let me show you. As you can see, I'm logging in for the second time. Only key-based authentication is used, without a one-time password. To recap, for SSH, single authentication type is sufficient to log in. If you want to have more than one authentication type, like 2 distinct keys or a key and one-time password, you need to set authentication methods parameter. In SSH, you can set various options for different users or groups by using match user or match group parameter. You can also protect your sudo access with one-time passwords by opening the sudo file and adding the module there. I will add null OK and echo verification parameters so that users that don't have Google Authenticator configured will still be able to use sudo. Let's try executing the sudo command. As you can see, we are prompted for a code and also a password. If we execute sudo one more time, it will no longer ask us for the password, as this is a default sudo behavior not to ask for a password for next 15 minutes. We can override that for sudo to ask for the password and code every time. It's also possible to skip the second factor authentication if the connection is from within the local network by using access file parameter of PAM access module. Adding Google Authenticator as the second factor is easy and can be applied in various places,